Hello, hi Vanira. Can you please confirm am I audible or not? Yeah, thank you so much. We'll be starting within 5 minutes. Let's wait for the Sujan and then we'll start. I think we can start now. So, good evening all. My name is Ritu Singh Sajawat. I'm Prime Minister's Research Fellow in Department of Earthquake Engineering from IIT Roorkee. I'll be acting as an additional teaching assistant for the course NOC 24 C85, which is Finite Element Method and Computation Structural Dynamics. This course is currently being tutored by Professor Manishi Khande, who is Professor in Department of Earthquake Engineering, IIT Roorkee. So those who are joining this session for the first time, just a little introduction about the sessions. These sessions are particularly meant for interacting with our learners of this particular NPTEL course. We'll be discussing some of the important concepts which will be helpful to you in solving the assignment problems related to this week. Also, we'll be solving some of the sample questions which are concerning with this week topic, and that will also be helpful for you to solving the assignment questions of this particular week. Other than that, if you are having any doubts related to the particular course or specifically to this course, you can ask. We can try to help you out as much extent as possible. And any other technical or non-technical query which you want us to address, please feel free to ask. Also, we'll be uploading this to our videos to our YouTube channel, and you can either attend the live sessions or you can watch these videos at the latest stage. At the latest stage, if you are having any doubt, please post your query in the comment section. We'll try our best to address your queries. So let's start with our session today. So the question number 1 is given to you. So today we'll be having only one question, and whole 2 hours we'll be solving this particular questions. And here we are having some of the uh, concept, like some of the related problems to the finite element formulations. Today we'll be dealing with some of the curved element. You need to first evaluate the shape function and the interpolating polynomials for the curved element, and among that then you need to evaluate what are the strain components. So here is the first question in front of you. So consider the mesh which is given below. Okay, the figure has been deleted. No problem, I'll draw the figure for you. So this is the figure. The coordinate of first node is 0, 0. There is 1, 0. Yeah, so this is the Kirchhoff plate bending element. You are having the two plate bending elements, which is first is number 1, second is 2. The corresponding coordinates of the nodes are given to you. At each node, numbering degree of freedom must be in sequence w dou w by dou x, dou w by dou y, where w is the deflection along z direction. The plate deforms under certain loading such that all the degree of freedoms at nodes 1, 2, 3, 4 are 0, and at node 5, 6 are given by. So at node 5 and 6, the displacement uh, vector is given to you, and at 1, 2, 3, 4 all the degrees of freedoms are having the 0 forces. The thickness of the plate element given to you is 100 mm. Now you need to first evaluate the values of shape functions, which is the shape function of n1 and n3 at the point 25 and point 3 for first element. Then you need to evaluate the values of shape functions n1 and 3 at point 1.5, point 3 for second element. Also, you need to evaluate what are the strain components at the midpoint of element 1 at the top surface, and then you need to evaluate the strain component epsilon x, epsilon yy, gamma xy evaluated at the midpoint of element at the top surface. So yeah, question is given to you. This is your particular element. Let me draw it here so you can read the element, read the question as well as solve the element. solve for the first part. So for such type of element, the approximate function which is given to you is given by. So in this case, at every node you are having three primary variables, which can be written as w, dou w by dou x, dou w by dou y, right? Where w is the deflection in z direction. So for this particular part, you can write w as a naught plus a1x plus a2y plus a3x square plus a4xy plus a5y square plus a6x cube plus a7x square a7x square y plus a8 xy square plus a9 y cube plus a10 x cube y plus a11 xy cube. So this is your w function. Now you also need to evaluate dw by dx, which is a1 plus 2a3x so okay, we will do this all calculation with maxima today. So we'll do this calculation. So accordingly we need to evaluate dw by dx, and then you need to evaluate dw by dy. Once you will have this, so this is your interpolating polynomial. Then you need to evaluate the shape functions. Shape functions you can evaluate with the help of the PC inverse, where C is your coordinate matrix and P is your polynomial matrix. Right? So once you have this, you will get n as some vector, and then that will give you what is your shape functions. Once you are having shape functions, then this will be like, since we are first evaluating the shape function for first element, so local for one element, you are having the 4 nodes, and in each node you are having 3 degree of freedom. So overall the size of this shape function matrix is 12, 1, and then you will be evaluating the first and the third value, and in that then you need to evaluate n1 for our coordinate system. How much is given? 0.25 comma 0.3, and then you are having n3 as n3 0.25 comma 0.3. So let's solve this thing with the our mathematical solver, so that will be helpful. So let's do this with mathematical, like one of the numerical tool which I having, which is very helpful in performing the your complex algebraic equations, performing operations with the algebraic equations. So this is one of the mathematical platform which will be very helpful, especially for this particular course where you are having the complex calculations doing with the hand. It's a bit complicated, that's understandable, and that's why let's do with this. So we know first we need to give the uh, first we need to give the polynomial. So first we need to define the primary variable. So let's go with the primary variable. So you know primary variable is given as w x comma y. You can directly write in this, and that will give you the part. So you are having a naught plus a1x plus a2y plus a3 x square then you are having a4 xy plus a5 y square plus a6 x cube a7 x square into y plus 8 x into y power 2 plus a9 into y cube plus a10 into x cube into y plus a11 into x into y cube. So for running this command you can just press shift enter, and yeah, this is your initial approximate polynomial, which is your a naught plus a1x a2y a3x square then you are having a4xy a5y square. So overall how many terms? You will be having 12 terms. So 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, so these are the 12 terms. Then next we need to evaluate dou w by dou x and dou w by dou y. For doing this you can just write the take the derivative of the above function with respect to x and with respect to y. So we can give the variable name as define dw dx as a function of x comma y as and you can take derivative. So for learning this particular commands you can refer any of the tutorial session available on the YouTube, or these are just the basic commands. You can follow the commands which I am writing, and that the same commands you can perform in your for your part also. So we need to take the derivative of wx comma y with respect to x, and that too we need to take the first derivative. For running this command, just need to check the parentheses. And then yeah, so there are some let me check the parentheses. So this is the part, this is this part, and then we'll be having one more parenthesis. Yeah. Okay, so that's wx comma y with respect to 1. Yeah, and I can just delete this. Define dw dx x comma y comma derivative of w x comma y so this is d by dx. So yes, we can take the form of this. And then you can just take the dw dx x comma y. So you also need to evaluate this. Input is dw dx x comma y comma derivative of wx comma y. So I just check it if I can find this thing. That's no problem. The derivative, let's set that. dx x comma y. Then take the derivative of w x comma y, then x. First derivative you need to take this, and for running the command you can just play w enter. It's not printing the polynomial. Let's check with that. Why so? Okay, it's a1 into x, a2 into y. Let me take this which I'm having with me. Yeah, not so. So it's a0 plus a1x. What is the mistake I was making? So I haven't put the product sign between this. That's why it's not calculated. So then let's take the derivative with respect to y. Define dw dx of x with respect to y. Then let's check what is the value. Yeah, so this is the derivative with respect to y, and once you have this, what is our next thing? You need to evaluate the shape functions. So for the shape functions, first you need to write the p polynomial matrix. So you know your polynomial matrix is given by, so this p can be written as 1 x comma y. So this is your particular column, 1 x y. This is your x raised to the power 2, 1 x y, x square. And you are having x y, then you are having y square, x cube, x square y, xy square, y cube, x cube y, and then you are having xy cube. So this is a particular polynomial matrix. The coordinate matrix is basically given as, for your first element is x1 y1, x2 y2, x3 y3, x4 y4, which is your coordinate matrix is given as. So for first element, your 1 is 0 0, your second coordinate is 1 comma 0, your third coordinate is 1 comma 1, your fourth coordinate is 0 comma 1. Right, am I correct? here. So this is your part. So let's incorporate this thing into our maxima code. So let's define your polynomial function. So px comma y is given as px comma y is given as 1 x y, then you are having x raised to the power 2. So this is your matrix. So first you need to write the matrix form. So matrix of these all particular elements: 1 x y, x square, x square, y square, x cube, x to the power 2 into y. Also we need to put the comma since this is your vector. X cube, x square, y. Or you can just take directly from here, and then you are having x y square, then you are having x cube y, then you are having x y cube, right? So let's close the matrix, and then what is the issue is not a prefix operator px comma y. Equal to matrix. One x y, x square, x y, y square, x cube, x y square. Okay, there's a x cube. Now let's see. Let's check the code again. Pxy matrix. Okay, this is y cube. This is x paste it from here, control C.
So matrix we are having x y
x square y, x y, y square, x cube, x. And let's check that. Yeah, so this is the code. So you are having the matrix operation given as x y, x square y, x y, and this is your polynomial matrix. Once you have this, you need to define the derivative of p with respect to define dp dx x comma y derivative p x comma y x comma 1, and then again parenthesis, and then let's run this. So here this is your dp by dx with respect to x. Then you have to define the dp by dy. Same function, you need to take the first derivative with respect to y. So here this is your dp by dy. So once you have this, so your p matrix is ready. This is your p vector. Now you need to take the coordinate matrix. So your coordinate matrix, you need to define the each element. So first is your x1 0, then x1 y1 is 0. So let's define the, so this is your column vector. So this is x2 is also 0, then this is your x3 which is 1, then sorry, here for the row part we need to use the semicolon, then x4 is 1, then you are having y1 which is a 0, then this is your y2 which is a 0, then this is your y3 which is a 0, so y3 is 1, and then your y4 is also 1, and sorry, here your x2 is 1, your x3 is 0, your x4, so the x3 is also 1, x4 is 0, y1 0, y2 0, y3 1, y4. Yeah. So this is your coordinate part. So once you have this, so now your C vector is ready. Next, you need to, so this is your coordinates you have to define. Once you have defined the coordinate, then you need to define what is your coordinate vector, C vector. So C vector is given as matrix. So sorry, this was your coordinate system, whatever coordinates which you are having. Your C vector is basically given as, you know, it's given by p of x1 comma x1 y1, p of, then you are having dp by dx of x1 y1, dp by dy, so yeah, dp by dx x1 y1 dp by dx is x1 y1, then same will repeat again, p x2 comma y2 dp by dx x2 y2. This is your whole row vector, dp by dy x2 y2, and this is p x3 y3, and this is your dp by dx x3 y3 dp by dy is your x3 y3, and this is your dp, sorry again p, so p is your x4 y4 dp by dx is your x4 y4 dp by dy is your x4 y4. So this is your row vector which is of size 1 by 3. Then let's put this. So this is your C matrix. So once you have defined your coordinates, you can write it like this. So this is your px comma y. So first is your p x1 comma y1, right? Comma dp dx and similarly you need to write for all the coordinates x2 y2 also. x2 y2 x2 y2 x2 y2. x4 y4 x5 y5 x6 y6, sorry, this is your x4 y4, your x4 y4, then parenthesis close for the matrix, and then let's see what is they get. Oh, what happened? We haven't defined dp by. Okay, here it's dp by dx, here it's dp by dy. We have named the same, dp by dy. Then let's perform this again, this again, this again. Yeah. So this is your C matrix. So for all the we are having px1y dp by dx. So this is particular your row vector. So this is not the 1 by 12. This is basically 12 by 1. Oh, basically if I'll break down all the elements, how many rows you are having? 1 2 3 4 5 6 7 8 9 10 11 12. So this is 12 by 12. So once you have this, you form this matrix. Now you need to, like, now each matrix is having a row vector embedded in this, but you need to make this matrix as the global matrix. So for that particular part, we'll use the command c1, which is given by mate underscore unblocker is c1. Now it's c, right? So this is your, yeah, so the whole matrix has been, okay. So once you have this, you can define your, so your C matrix is ready, your polynomial vector is here. So once you have this, you can define your shape function, which is given by, so PC inverse. So C inverse is 12 by 12, P is your 1 by 12. So your shape vector will be 1 by 12. So this is given by define, and like, let's say this is for the first element, so I'll put it as n1 x comma y p x comma y. So you need to define n1, so you need to multiply pxy with the inverse of c1. So for the inverse command, we are having the, for doing the inverse, we are having the command is invert, and we could get inverse of c1. So once you are having this,
There is some issue with the parenthesis.
define n1 x comma y comma p xy c1. Okay, here we are at, take one more parenthesis, dot invert c1. Now let's perform this.
Okay, there's some error. Let's check that what it is.
Let me write it again. So this is your define n underscore 1, which is the function of x comma y, can be defined as your polynomial matrix, which is x comma y, which you need to multiply it with the inverse of c1, your polynomial matrix. And let's check what is the issue. We have done this here.
Same error. Okay.
given by n underscore 1 x comma y pxy, which will multiply with the inverse of c1 into some matrix. We are getting it as wrong. So let's check that where we are wrong. dp dx dp dy x1 y1, then px2 y2 x2 y2 x2 y2. Okay, so it's taking, so somewhere our calculation are done wrong. So I'm having the final answer xy a1 a11 y cube a8 y square 3 a 10 x square y 20 a7 x square a4 y 3 a6 x square 2 a3 x plus a1. Then here we are having 3 11 x square 3 a9 y square 2 a8 x square 2 a5 y a10 x cube a7 x square a4 x and a2. Then your w is correct. Then you have defined the derivative dpy dy dp dx dp dy x2 y2. Then let's set our coordinate. So our coordinate is given as 0 1 1 triple 0 double 1. Okay, then it's px1 y1 dp dx dp dy px2 y2 dp dx x2 y2 dp dy x2 y2 px3 y3 dp dx x3 y3 dp dy x3 y3 px4 y4 dp dx x4 y4 dp dy x4 y4. So we are having whole thing as correct. Let me check where we are missing it out. So x1 is 0, x2 is 1, x3 is 1, x4 is 0, y1 is 0, y2 is 0, y3 is 1, y4 is 1. So we are having C matrix dp dx is correct and your dp dy is correct. P is your x2 y2 dp dx x2 y2 dp dy. Once you have defined this C1, unblock the matrix. Not sure where we are doing the mistake, but yeah, I think the matrix is becoming singular, which shouldn't be the case. So let's see. If I put the same code, I guess I make mistake in writing this. C matrix.
y cube this is your P matrix. Let's replace it here. Then this is your dp by df matrix. Okay, now it's correct. C1 mat block C. Okay, let's check. Then we are having this. Then we can move this. Once you have removed this, then you can perform operation on this. And then this is the command which I'm having. You are having this, and then yeah. So let's minimize this code time. So this is our particular code. So first you have defined your W matrix, then you have defined the derivative of your interpolating polynomials, then you have defined your polynomial matrix, then you have taken the derivative of that polynomial matrix with respect to x, with respect to y, and then you know how to form the C1 matrix. So that is given by px1 dp by dx dp by dy for all the four coordinate system, for all the four coordinate set which you are having, and then you will evaluate C1 since these are the internal matrix available here, so you need to unblock this. So you have unblocked this, and then you have defined the N1 matrix by taking the PC inverse. So this is your final shape functions which is available with you, and once you are having these shape functions, so this is your for first coordinate first node. So for 4 you are having this N1, N2, N3. So among this in the question which has been asked, you need to evaluate 8 N1 and N3 at 0.25 and 0.3. So for doing this, what we can do, you can write this particular system. Let me close this. And then you can write N1, and then you are having the for shape functions. So first we are having the in the question it has been asked N1 and N3 at 0.25 and 0.3 for element 1. So this is your particular N1, this is your N3. So this is how you can evaluate. So your overall shape functions matrix is having your N1, and this is 0.25, 0.3, and this is your shape function matrix. You need to take the third row, third vector of that, and then that will be your third element of that, and then you will be having 0.25, 0.3. So this is your particular answer available with. So how to derive this? So I think you can also do by hand. Just wanted to show how you can use a maximum. So this is a particular formulation. So first you need to finalize what is your primary variables,
Then you need to take your approximate interpolating polynomials. You need to take the derivative of this, and then you need to take the shape functions. How you will evaluate the shape functions? So first you will be having the polynomial vector available with you. You will multiply it with the inverse of c, and once you are having the inverse of c, you can get the shape functions. Your p vector is the having elements which are corresponding polynomials in your approximate functions, and once you are having this, this is your c vector, this is pxy, and corresponding derivative of this. So once you have this, you can evaluate your n with the help of pc inverse, and that will be giving you the your corresponding shape functions. And once you will evaluate the shape functions, so you can take the n1 and n3 here as I've been asking the question. So your first point of interest, and then your another point of interest. So this is how we are going to proceed. So that was a little overview about like how you can use the maxima. So yeah, during the operations you will find some of the errors that you can debug only by having an practice over the tool. So let's move to the second part of this question. So once you have this, now you need to evaluate the value of the shape functions at point 1.5 comma 0.3. So the whole procedure is same. The only part is you need to change your coordinate system. So let's see whether we can use the same code or not. So the only part, now you need to change your this particular coordinate system which is given by x1. So now for the second element, definitely all four coordinate set will get changed. Let's check what it is. This is your x1 comma 1, x2 comma 2, x3 comma 2, x4 comma 1, y1 comma 0. So y2 is to 0, y3 is to 0, your y4 is to 1. So x1 1, x2 2, x3 2, x4 1, y1 0, y2 0, y3 0, and y4 1. So we'll run this. Yeah, this is a new coordinate system. Once you have this, the only part you have to repeat, you need to again form your C1 matrix for the second element. Let's say I'll say it as C2. You can just paste the code here
and then let's say I'll name it as C2. Then let's run the command. This is your new set, and then again you need to unblock this matrix. Let's say this is your C2, and then this is your particular part. So once you have this, you can define your second set shape function matrix for the second element, which you can give it as define underscore. You can copy paste the same command over here. So this is your same command, define m2, and then you just need to take the C2 here. Again there is some issue. What is that issue? Pxy dot invert of C2. Just change the thing. Okay, this is your n2 px over y dot invert of C2 by showing it like this: 0 1 0 3 0 0 1 0. Let's see whether our coordinates are correct. Okay, this will get changed. So for the second element it's 1 2 2 1, then you are in 0 0, then your y3 is 1. Yes. Okay, 1 2 2 1 0 0 1. Now we can evaluate this again. We can unblock this again, and then now we can evaluate what is here. So this is your shape functions for the second element. Now what is our point of interest is the one and third element again, as has been asked in the question, and the coordinate which has been asked for this particular thing is 1.5, 0.3. This is also 1.5, 0.3. Once you have this, you can run this, and this is your values of the shape functions. So it's 0.25 or how much? Yeah, so answer which I'm having is 1.5, 0.3. Yeah, this is second we are defining. Yeah, so it's 0.392 and 0.3. So the same procedure again. The only part is you need to just change the coordinate system which you are having with you. One second, I'll do this. You just need to, for the second element, you need to define the new coordinate sets which are there with you. same part, only thing is your coordinate system will get changed. Which is your x1 is 1, y1 is 0, x2 is 2, y2 is 0, x3 is 2, y3 is 1, x4 is 1, and then your y3 is 1. So this is the particular set you need to take into account, and once you have this, you can put in the same code which you have taken, and then you can calculate your part. So yeah, that was like we have simplified the problem by reducing your computational efforts or your calculation efforts. You can use this maxima functions, maxima tool available with you. This will basically help you in simplifying your algebraic expressions, or let's say your matrix operations. So in that way you can evaluate whatever values you are getting, and that too in very less efforts. Once you are having code ready for one particular aspect, the same code you just need to alter the very minimal values, and then you can simplify that. If you want me to take a special session on the maxima tool, just you can ping me on WhatsApp, sorry, on YouTube, and then we'll see whether we can take that problem, or we can organize a particular session particularly for that. So that was your first and second part. Then we'll go for the third part. You can try with that. So let's go for the third part. So we have solved this first and second part. Now just read what is the third part. Then we'll solve for the third part also.
So now let's see this particular part. So now um, we'll be solving the third and fourth pieces. Third and fourth part. Let me reshare it again. So your third part, it has been asked, you need to evaluate the strength component, which is basically your epsilon xx, epsilon yy, gamma x at the midpoint of element 1 at the top surface. At top surface. So if this is your particular figure, so this is your element 1, so this is your top view. If you see the side, so this is your one particular plate, then which is connected to the next plate. Then you need to figure out what is the strain condition at the midpoint of this at the top surface, right? So uh, you know, strain curvatures, strains and curvatures, how they are related. So you know, curvatures for any part from simple bending theory, if you know, your curvature is basically given by 1 by I is equals to f by y is equals to e by r. So this is your radius and 1 by r is your curvature. So utilizing this, you know, your moment is given by e d2y by dx square. This particular aspect, we generally say it as a curvature, right? So if we see in the three-dimensional, your curvature vector is given by kappa xx, kappa yy to kappa xy, which you can relate it like this. Dou square by dou x square, dou square by dou y square,
then this is your 0 0 element 0 element, this is your 0 0 dou by dou y dou by dou x, then your displacement vector is given by dou w by dou x, and this is your dou w by dou y. So this is your curvature matrix. Utilizing this, which can also be written as minus z dou 2 square n1 by dou x square dou square n2 by dou x square, and similarly you will do it like this, p square n12 by dou x square for your particular plate element case, and this is how you can w1 theta 1x theta 2x theta 2y, and this is your theta 4y. So how we are going to relate it? So epsilon xx epsilon yy gamma xy, this is how you are going to relate it, minus z dou square by dou x square dou square by dou y square 0 0 0 0 0 dou by dou y dou by dou x, and then this is your particular shape functions n1 n2 n3 n4, which will go up to n12 dou n1 by dou x dou n2 by dou x dou n3 by dou x dou n4 by dou x dou n12 by dou x. Similarly, you need to take the function with respect to y, dou n2 by dou y dou n3 by dou y dou n4 by dou y, this is your dou n12 by dou y. And similarly you will be having, you need to multiply it with the displacement vector, which is given by w1 theta 1x theta 1y, which is your theta 4y, and sorry, this you need to take transpose. So this is your displacement vector. So this is your displacement vector, and this is how you need to take the help of the shape functions matrix available here, and you need to use the differential operator, and you can further evaluate what are your strengths. So again you can take the help of the maxima for calculating this. Let's solve this. I'm not sure to what extent we can do this, but let's see till whatever we are possible. So I'll share the maxima screen again. So we are already having the shape functions available with you, we just need to take the second derivative of that. So let's do this. I'll take the help of it. So first let's take the let's me give you the final expression which we are going to take. Stop presenting. I'll share the entire screen so that won't be an issue for you. So if you see, guys, I'm not don't know why my stylus is not working. Take the help of this. So you know what you're having. So your final matrix is given by minus z, so dou square n1 by dou x square dou square n1 by dou y square then you have 2 dou square dou n1 dou x dou y dou square n2 by dou x square dou square n2 by dou y square 2 dou square n2 by dou into dou x into dou y dou square n12 by dou x square. Similarly, you will be having dou square n12 dou y square. Here you will be having 2 dou square n12 dou x into dou y. So by taking the help of this, so this is your w1 theta 1 x theta 1 y up to theta 4 y. So this is your particular. So once you are having this, so our ultimate goal is to evaluate all the values of the shape functions. And once you are having this, you can evaluate the particular stream here, right? So let's do this thing here. So first you need to take the derivative with respect to x, then derivative with respect to y, and then you need to do it for the first element, then similarly you need to do it for the second element, and then you can finally find it out. So first you need to do it for this element, all these elements. Once you have this, for you will calculate for all these elements, you can get to know what are the strings. What is our point of interest? So it has been asked, you need to evaluate at the midpoint of element one at the top. So epsilon x epsilon at the midpoint of the element of the top. So let's calculate the strain displacement. So we are having dou square n1 by dou x square. So I'll define this d2 n underscore 1 d square n1 is given by dx square x comma y. Then you have to take the derivative of your first set of functions, shape functions for the first element. We have already calculated what is the shape function for first element here. So this is your n1, and then we are having the n2 for the first element. So those were the shape functions for the element 1. These are the shape functions for the element 2. Then you need to take the derivative of this, which is given by n underscore 1 x comma y comma x comma 2. So these are your first part. Then you need to take the derivative with respect to y. And that is your dy square. Then you need to take the partial derivative with respect to both x comma x and y. So this one is given by dx dy x comma y, and this is how you can do a derivative. Then you take the double derivative. So derivative of n1 x y comma y with respect to 1 once you can have this, you can define this. So you are having the required derivatives and the required partial derivatives with respect to x, y, and both with respect to x, y for our first element. You can utilize this, and then you can define a vector, which define a matrix which will be having all the three parts. So you can connect them with the row wise element. can take the all of this. T2n dx dy xy this is your P1 matrix. Yeah. So for your shape function, so this is how you will define for your element one. So this is your strain displacement matrix which is you are having. So there is B vector you are having. You can take the shape functions, derivative of the shape functions which you have evaluated, and similarly now you can evaluate for the second element also. So for this we'll copy this. So let's go for the, we just need to change the and for d2 and 2. For second element I'll just replace 2, here I'll just replace 2, and this is my shape functions for the second element with respect to x, and this is my shape function for with respect to for second element with respect to y, then this is my shape function for second element with respect to both x comma y. Yes, so this is how you can calculate this part. So now you are having the displacement vector available with you. Once you have this, again you need to define the displacement vector for second element. For this you can solve it like this. This is to define v2, and then in the place of n1 you can just replace n2. So this is your strain displacement vector, a strain displacement matrix for your second element. So once you will get this, then now you can evaluate what is your Once you have this, now you can evaluate what is your B matrix for both element 1 and the element 2. So I won't do the further calculation since we are near the time. I'll just show you how it's been done. So I'll unshare this part. Uh, so we have taken the part, so we have calculated. So we have calculated this matrix for both element 1 and element 2. Once you have this, now your epsilon xx, epsilon yy, and your gamma xy. So what we have checked here for calculating this, since you have already got this matrix, now for calculation of this, you just need to do with the z. What is the z? So the thickness of the element is given as 100 mm. So you know your z is the distance from the neutral axis. For this particular plate element, your z will be 100 by 2, which is 50 mm, which is your 0.05 meter. Yes. So for this vector, once you have this, you can calculate minus z into b1, and you know your displacement vector, you can evaluate this. So this is your b1 transpose. You know, so again the b1, b2, b3, b1 and b2 which you got, you need to put the xy coordinate for the element 1. So you can get that, and so that will be your, so that will be your b1 once you will put your xy coordinate. And then here you need to put your displacement vector, and once you will get this, your final answer which you will be getting is 5 into 10 raised to power minus 4, 5 into 10 raised to power minus 4, and here is 0.0095. Similarly for the, this is for your element 1, which we have evaluated at midpoint. Similarly you can get for the second also, and the for final answer for second which I am having is 5 into 10 raised to power minus 4, 0.00125, and this is 0.009125. This is your for your element 2, and this is also we are taking at the midpoint. So that's all for today. This was our final answers. So today we have taken a new approach, like we have solved using the maxima. So you can watch these videos and also perform your calculation with the alpha of the maxima. You will face problem at the initial part, but once you will be equipped with that, you at the further at future you will perform this operation so smoothly. So let me unshare it. So that's all for today. If you have any further query, please feel free to ask, and if you have any query when you watch this video, you can post your query in the comment box. Definitely we are going to discuss this, as you can also come to the next class which is on the next Tuesday. So if you don't have any query, like if the like attendees who are attending the session right now, if you don't have any query right now, we'll meet next Tuesday at 6 p.m. Thank you so much.